Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A molecule has a plane of symmetry, mirror plane, if there exists a plane that divides the molecule into two halves that are mirror images of each other. A molecule with a plane of symmetry is achiral, it is a mesocompound or otherwise symmetric. Moving on to the next step. Analyze option C. Structure C shows a 6-membered ring with 4 substituents, 2 carbons on top each bearing H, wedge, and cyclopropyl, wedge, I, both pointing up same face, and 2 carbons on the bottom each bearing H, wedge, and cyclopropyl, pointing down opposite face. The molecule has a horizontal plane of symmetry passing through the middle of the ring, between the top 2 and bottom 2 carbons, or a vertical plane of symmetry bisecting the left and right halves. In structure C, the top 2 carbons are mirror images of the bottom 2 carbons through a horizontal plane, making it a mesocompound with an internal plane of symmetry. Therefore, C has a plane of symmetry. Moving on to the next step. Analyze option A. Structure A shows a cyclohexane with cyclopropyl groups and H atoms arranged such that the cyclopropyl groups are all on the same face, all wedge or all dash relative to the ring plane. This is an all-CIS arrangement. While it may have a C3 rotation axis, the three-dimensional arrangement of groups in structure A with the depicted geometry does not create an internal mirror plane that maps the molecule onto itself. The structure is chiral, no plane of symmetry. And for the final step, analyze option B. Structure B shows an asymmetric arrangement of cyclopropyl and H groups around the ring, 2 cyclopropyl on one side, 1 on the other in a specific pattern. This arrangement lacks a plane of symmetry and represents a chiral molecule. Conclusion. Only structure C possesses a plane of symmetry due to its symmetric meso-like arrangement where one half of the molecule is the mirror image of the other half through an internal mirror plane. Therefore, the correct answer is C. Therefore, the correct answer is option C.